Hello and welcome to the video. In this video, I'm going to tell you about the new features for MagiCAD 2025 UR-1 for Revit and for AutoCAD. This video will be divided into two parts. In the first part, we'll go through MagiCAD for Revit, and in the second part, through MagiCAD for AutoCAD. Below this video, you can find the timecodes with which you can easily navigate through the features. Let's jump to the explanation and we will start from Revit. Easily check that flow damper placements meet safety distance requirements. Let's go to Modify Dataset. Then under Ventilation, find Product Safety Distance Checks, and let's create the new Product Safety Distance settings. Let's give a name. For example, it can be test, and I'm going to copy this name to the description too. And dampers usually need undisturbed airflow to work properly, which means that their placement requires detailed consideration to avoid errors that may affect their performance. So here you can assign the safety distances for circular and rectangular ducts. Here you can see the number n, and here you can see the tip how the safety distance is calculated. For example, in this case, n is multiplied by diameter. For rectangular ducts, n is multiplied with the a value, and you can choose the meaning of the a value. So it can be the long side, it can be diagonal of the damper, and also it can be hydraulic diameter. Let's assign n to different situations. And here I'll assign 5, for example. And also, let's assign some values for rectangular ducts. And here too. Okay, I'm clicking OK. Let's close the window. And then go to MagiCAD command to design data. And it's really important to go to Product Safety Distance Check and copy this item to current project. Okay, let's close the window. And then let's install dampers. After damper installation, we should go to Calculation and to Extend Flow Analysis. Here in the Product Safety Distance Check, from the drop-down list, you should choose the safety distance settings that you want. And also check this option, Override Manufacturer Defined Distances. Then let's click OK. Let's choose the object. And then when the calculation is performed, you can see the warnings in the places where the distance to damper is too short, according to the damper safety distances settings. New options in the device connection tool enable easier A terminal connection. I have an A terminal and a duct here. Let's connect them. For this, let's go to MagiCAD Ventilation tab, and then let's choose the device connection function. Then I'm choosing the air terminal and then the duct. And here you can see the preview of the created connection. But the functionality now has newest option, length from duct middle point. So right now it's 250 millimeters, but let's change it to 1000 millimeters. And then you can see that this branch was moved. Also, you can use flexible duct to connect the device. It's not visible on the preview, but you can see this on the plan view. Also, you can change the distance of the flexible duct. Like, for example, I'll change it to 200 millimeters, and the flexible duct will be shorter. And also, you can compensate height difference with flexible duct. So the flexible duct will go like this. And the same functionality is used for the multiple device connection. So the length from duct middle point. It's possible to use flexible duct to connect the device. And also you can compensate height difference with flexible duct. Manufacturer A-terminal products now include throw length data. Throw length are included in every DIALux where A-terminal product properties are shown throughout the project. So let's go to the properties, for example. And here it is, the throw length. Also, if we perform some calculations, and then let's go to the properties of this air terminal. And the throw length is shown also here. And of course, in the product properties, you can see the throw length tab. The improved standard connection tool supports several new connection scenarios. This functionality can be used for ventilation, piping, and electrical, but I will use ventilation as an example. So let's take a look at the first scenario. So here we have the perpendicular segments to one main segment, and all the segments have the same system classification. Let's connect them. So I'm using the multi-standard connection tool, using all the objects that I would like to connect. And then you can see here the tip. What should you connect? I'm going to choose the first pair, and I'm choosing first of all the main object, and then the segment. And right now all the ducts are connected. The ducts were located at the same elevation, and that's why you have only one options for angle. 0, 0. Let's click OK. Then, the second situation is a bit different because the ducts are located on the different elevations. I'm using multi-standard connection tool again. I'm choosing all the objects, then the first pair, and then you can see different options for the angle. Like this. But for example, I'll choose 45 degrees. Okay. Also, the tool now maintains correct spacing between segments when multiple segments are connected end-to-end simultaneously. The third situation is the following. I have 6 parallel ducts, and I want to connect their ends to each other. This time, let's choose the multi-standard connection tool when I'm choosing all the elements manually, and then I'm clicking Finish, and I'm showing the first pair like this. And here you can choose the angle options. The fourth situation is a bit different because These ducts are located on the different elevations, but this tool can manage this situation too. 45°, 30°, 20. The next situation, we have 4 parallel ducts, and I'd like to connect this duct to this and the end of this duct with this end of this duct. I'm choosing the objects, then I'm showing the first pair. The workflow is always the same, and then I can change the angles. Great. And the last situation when we have parallel ducts on the different elevations, like this. The first end, the second end, and here's the result. Connect multiple drainage devices simultaneously and create vertical drainage pipe connections. I had 3 different situations with vertical and horizontal pipes. Let's start from the first situation. Here we have the horizontal pipe, and the offset of horizontal pipe is higher than the top end of vertical pipe. So I'm choosing the drainage connection tool, select a device option, then I'm choosing first the vertical pipe, and then the floating bar appears with 3 different options of connections. In this case, I'll use top connection of a vertical pipe. And then I'm choosing one of the open ends of the horizontal pipe. And then you get the connection. You can choose different angles and also connection types. The second situation looks like this. So there's a riser and then a horizontal pipe. I'm choosing the vertical pipe. And then this time let's choose the branch connection of a vertical pipe. And I'm choosing the middle of the horizontal pipe. Then we have the following connection. You can change the branch angle. Okay. And then the last situation, when the horizontal pipe is located lower than the bottom end of the vertical pipe. And this time I'm choosing the middle of the duct. And here you also can choose vertical elbow angles. Right now it's 90-0, but for example, it can be divided into 2 elbows with 60 and 30°, 45, and 30-60°. Multiple drainage devices can now be connected simultaneously instead of creating connections one by one for each device. I'm using the drainage connection tool. Then I'd like to choose multiple connection option, and then I'm choosing all the devices that I need to connect, and then I should use a drainage pipe. Please don't forget that in the lower left corner you can see the tips for your actions. Then I'm choosing the point, and the devices will be connected. Also here you can choose the vertical elbow angles. For example, you can divide one 90-degree elbow to 245 degrees elbow. Of course, you can change the branch angle. You can replace last branch with elbow like this. And let's imagine the following situation when the connector of the drainage device is located on the side of this device. So let's choose drainage connection with multiple selection option. I'm choosing all the devices and then the pipe. And then despite the drainage connection was located on the side, because we've chosen the rotate automatically option, the connection rotated to the correct position. If I'm unticking this rotate automatically option, we can't get the connection. MagiCAD now allows you to convert any part of piping network from rigid pipe to flexible pipe. Let's go to MagiCAD piping and then let's choose convert to flex option. Previously it was available only for sprinklers. And then you should select fitting component or device for starting point. In this case, I'm choosing this manifold as the starting point, and then you should choose the pipe. And as you can see, the pipe became flexible. Here I can choose the flexible pipe series. Also, you can define the length. For example, 500 millimeters. Don't forget to update. And only this part became the flexible. The conversion is done onwards in the selected direction until the next element that is other than a pipe, bend, or reducer. Let's take a look at this situation. I want this branch to become flexible. So let's choose our feature. Then I'm choosing this bend as a starting point, and then the direction. And as you can see, the functionality stops when it meets the T branch. The functionality works in the same way for sprinklers as previously, but don't forget that you have to create the special pipe series for sprinklers. The pipe segment should include the equivalent length. So to assign the equivalent length, you should go to MagiCAD create the flexible pipe series, and here for pipe sizes you can assign the necessary equivalent length. And then let's delete this pipe segment and I'll add the pipe from the very beginning. In the settings, you can choose a local database with your pipe series, but also there's a pipe series for flexible pipes in our cloud database. It's here. And don't forget to tick the option is flexible pipe. So then add this pipe series to the project. And that's how the function works for sprinklers. You should choose the device, the sprinkler in our case. And then here you can choose the flexible pipe, and then you can choose length from pipe series. easily change 90-degree bends to 2 bends of 45-degree or 3 bends of 30-degree and vice versa. For this, let's go to MagiCAD Piping, and then I'm going to choose Drainage Bend Converter tool. Here you have the option of single selection or multiple selection. I'm going to choose the option 90 degrees to 2 bends of 45 degrees with pipe. And the length between these 2 bends of 45 degrees will be 200 millimeters. So let's choose the vertical bends. Finish. And here is the result. And then let's combine these bends to one bend. And then let's combine these 2 bends to one bend of 90 degree. For this, I'm choosing this option, all the bends, and then I'm clicking finish. And you have the error. Pipe between bends is too long. Why? Because there is a setting for threshold, and it's just 10 millimeters. In our case, because the length is 200 millimeters, threshold should be bigger than 200 millimeters or equal to 200 millimeters. Okay, and now if we are choosing this option again, it works. Then let's see how 90 degrees to 3 bends of 30 degrees work. 1, 2, 3 bends of 30 degrees. Also, you can assign default settings in the settings window. Summarize heating, cooling, power, and supply. Extract airflow from devices and add the total value to a space. For example, I want to summarize the total flow of these extract A terminals. It equals to 36 liters per second, 36, and also 36. For this, you should go to MagiCAD Command tab, and here in General Tools, you will find the functionality HVAC to Space Parameter Linker. Here you can choose the products and also whether you want to summarize heating, cooling, or airflow. I'd like to summarize airflow, and then let's click OK. And then when you go to properties of the space, you will see that the extract airflow was calculated. Let's delete this device. The space properties will be the same. But with the help of Update HVAC to Space Parameter Linker functionality, you can update the flow values. And as you can see right now, the extract flow is equal to 72 liters per second. Also, this functionality works for VAV A terminals. For example, in this space, I have 2 VAV supply air terminals with the following values. So the minimum flow is 10 liters per second, the normal flow is 20 liters per second, and the boost flow is 30 liters per second. Let's use this option. I'm going to summarize airflow. Then let's go to the properties of the space. And then you can see that summarized minimum flow is equal to 20 liters per second. So 10 plus 10. Normal is 40, 20 plus 20. And also the boost flow is 60. And let's summarize also the heating power of this space. In the product properties, it will be called like piping power. So let's click at this option again. This time I'm choosing heating. Okay. And the piping power is summarized. The selection filter tool has been expanded to provide more filtering possibilities for users. For example, I'd like to filter these objects. Then I'm choosing the selection filter. And right now it's possible to add your own parameter. Like, for example, I'd like to add MagiCAD actual flow. It appeared in the list. Then I'm going to untick other parameters. And then let's use this option and refresh. And then, for example, I'd like to choose the air terminals with the actual flow that is smaller than 50. Let's click OK. And all necessary air terminals are selected now. MagiCAD now supports the Polish domestic water calculation standard, including all building types covered by the standard. Let's go to MagiCAD command. Under MagiCAD command, move to Settings and to the Project tab. And under the Project tab, you can choose the standards. Let's choose the Polish standard, then click OK. And after that, let's go to MagiCAD Piping tab and let's perform the domestic water sizing. So here you can choose the building types that are taken from the standard. And because the standard doesn't define requirements for hot water recirculation, it is called return water here in the settings, MagiCAD offers a selection of velocity and pressure loss options for their sizing calculation. Then let's click OK. And the calculation based on the standard is done. The new Tag Multiple Segments tool makes it much easier to add tags to system segments. The 3 parallel pipes are presented on the drawing. Let's tag them. For this, go to MagiCAD command and then to Tag Multiple Segments tool. So here you can choose the category, cable trays, conduits, ducts, but I'm choosing the pipes. And the pipes here are located horizontally, so I'm going to choose horizontal option. For example, I'll choose this tag. And you can choose different options, like for example, you can change the leader line add. Also, you can override leader arrowhead. For example, it can be diagonal 3 millimeters. And then you can choose the orientation, horizontal. And let's tag. So first of all, you should choose all the objects that are going to tag and then click Escape. And then you should locate the tag like this. If you don't like the tag location, you always can move it. Right now, I'm going to create the tag with the vertical orientation. It looks like this. And you also can move it as you want. And now let's tag the vertical segments. I'm going to choose the vertical option now. Horizontal orientation. And let's try the same thing with vertical orientation. But also you can create your own tag. For this, click Create, then choose the family category, and then assign a name. For example, it can be testing tag. Let's click Create. And then the family editor opens. And here you can see a pretty nice guide how to make your own tags. But I still will show you what you should do. So first of all, you should click Add Label and then go to Edit Label option. Here you can choose your parameters. You can select a shape parameter, for example. I'm going to choose the diameter from the list. And I'm going to remove the comments from the label parameters. Let's click Apply and OK. After that, you can change the MC baseline length. It depends on the length of the text. And also you can change the vertical line length if needed. And then you should load the family into the project and close. And if Revit asks you whether it's necessary to save the family or not, you should click Not. And override the existing version and its parameter values. And then let's go to Tag Multiple Segments option. And here you can choose the tag that you've created. MagiCAD now supports the use of parallel power supplies for an electrical systems and single core cables. Let's go to MagiCAD Electrical, then to Wire. And here right now you can choose the multiplier, for example, 4. And the main point of this functionality is to use several smaller cables instead of one big and heavy cable for easier installation. Then you can choose the type of the cable. And you also can create the ground cable for your cable type. I'll show you how to make it a little bit later. But for now, let's draw the wires. And I'm going to close this window for now. And then if we go to the properties, you'll see the MagiCAD parameter, MC number of cables. It's 4. Then let's go to MagiCAD Electrical, then to Wire Type Management. Here you can choose the wires that will be in use in Wire Drawing tool. And I've created the ground wire for this type of wire. For this, you should choose the multi-core and separate protective earth options. And then for ground wires, you should copy all the options from the main type of wire. But here in the properties, you should choose single core and protective earth included. And then these types will appear in the drop-down list. Let's choose this circuit. And then I'm going to Manage Circuits option. And here you also can choose the wire type, the multiplier. Also, if it's possible, you can choose the protective earth wire type. Let's click OK. Save. and close. And then if we tick this option, MC copy wire type from circuit. For every wire. And then we go to MagiCAD common, update parameters, electrical. I'm going to deselect all and I'm choosing only wire data. Let's click OK. And as you can see, the multiplier right now is 10 because we assigned this multiplier in the Manage Circuits option here. And the weight per meter property is used to determine if a wire type should be considered a cable product, and the conductor arrangement dictates if the cable is considered a multi-core cable or a single-core cable. All the settings for single-core cables are taken into account in the bill of materials and cable out functions and when transferring electrical data to external calculation software. Import lighting plans from DIALux Evo into MagiCAD in IFC format. For this, let's go to MagiCAD Electrical tab, then to DIALux, and import from DIALux. And here you should choose the project in IFC format that you want to import. Then choose the stories for importing. For example, I'd like to choose floor 1, and the corresponding level in the project is the street level. Let's click import. And then you can map the luminary types to corresponding ones in MagiCAD, or define 2D symbols for the created luminaries, like in this situation. So I'm briefly assigning the symbols. Also, you can simply update existing luminaries according to the data from DIALux Evo instead of creating an entirely new design each time. But let's import. And luminaries are imported. MagiCAD now supports many new family categories that have been added to Revit recently. Let's go to Install Product. New family categories for LV products include fire protection under the fire product class, fire protection, audio-visual devices under audio-video, audio-visual devices, and nurse call devices under signal. Also, there are improvements in connection to mechanical. Let's go to electrical, to connection to mechanical tool. And right now this feature have expanding filtering possibilities. Like for example, project filter, level filter, and type filter. And the connection objects created with the function can now be indexed with the running index tool. Let's go to modify dataset, to variable settings, to running index, and to groups. I've already created a group for connections to mechanical. And then we can go to formats. And I also created the format. I assigned the group. And the validity is the following: other electrical connections to mechanical. Let's click OK, close. Then we should move to MagiCAD Common tab and to running index tool. Then I should choose the necessary group and the format. And I'm going to choose use automatic numbering option. And I'm going to choose the first level. And I want to show index after installation. Undo any number of the previous steps during wire drawing to go back without deleting the current wire. Let's go to Wire tool. And then I'm going to draw a wire. And you always can go back. MagiCAD support and hangers module has been updated to support Revit 2025. Electrical calculations have also been updated, and the international calculations now support Revit 2025. Localized electrical calculations are available for Revit 2023.1 and 2024. Multiple editions improved the usability of MagiCAD Room. Let's go to Project, then to All Rooms. A new column shows whether manual heat loss values are on or off. Let's check the dining room, for example. And as you can see, the manual value option checked. I'm going to change it to just randomly 2000, and then let's click OK. It's 2000, and when I'm checking the manual value option, the calculated heat value is shown. When importing and updating data from an IFC file, MagiCAD indicates which values were overwritten and which settings were updated during the process. Let's go to IFC Space Updates tool, and right now you can choose which values you can update. And when you are performing the IFC import, you are aware that this command destroys all structures, and you can import new structures. And the IFC4 export in MagiCAD Room has also been updated to use the full IFC4 schema. The IFC import of lighting plans from DIALux EVA has been improved, and users are now notified in case an imported IFC file is somehow invalid. Common reasons for this are, for example, missing story or building definitions. Let's go to MagiCAD Electrical to import export, DIALux import. And if an imported file only contains a single story, MagiCAD now proceeds directly to luminary mapping without unnecessary story mapping. Improvements to busbar modeling and product definitions. Let's go to MagiCAD Electrical, then to Electrical Cables, and to busbar trunking system. And right now, it's possible to use vertical T-branches when modeling busbar systems. Let's choose a point. And the vertical T-branch is created. And right now the default branch settings for fittings can be defined in the product datasheet. So let's go to project. Let's go to the project. Then to electrical, to busbars. And let's define the default branch length. For example, 600 millimeters. Let's click OK. And right now the default branch length is 600 millimeters. Let's go to project, and right now I'm going to change it to 100 millimeters. And then the branch length changed to 100 millimeters. In addition, if an installed busbar supply unit is not automatically connected to a switchboard, users are prompted to select a switchboard to connect with. So I'm going to choose supply option. And then we have a prompt, select switchboard. Create bus system reports and add them into drawing. Let's go to communication data and building automation, then to bus connections. And let's print this information about the circuits and devices to block. You can choose here different elements that will be shown: hosts, hosts and circuits, or hosts and circuits and devices. And also you can show the warnings in the report. Let's click OK. And then MagiCAD asks you to show left top corner. And here you can see the report. The notes section in the calculation report shows information that has been added to the notes dialog in the project file. Let's go to MagiCAD ventilation and piping, then to project. And then let's go to the information of the project, and here you can find the notes field. That let's perform the calculation for the ventilation system, for example, balancing for the supply system. Let's show the calculation report. And then in the general results, you'll see the notes. The improvements to calculation reports include the addition of missing differential pressure properties and the possibility to set system classification for heating and cooling subsystem pipes. So let's go to project, then to report templates, and here under the calculation you can see the missed parameters. There are separate properties for heating and cooling volume. Let's install the climate beam. And MagiCAD now includes separate properties for heating and for cooling volume for climate beam and fan coil unit devices. Separate heating and cooling volume values are also used with manufacturer products if this information is available. MagiCAD now provides additional information about underfloor heating loops for users. So let's go to part properties of this connection node. And here you can see the new properties such as adjustment values and pressure loss over valves for the connected manifold, the total length of the loops, the distance between pipes, and pressure loss over the entire loop system.